Let's talk about natural logs and the mathematical constant E. I know you've heard of other mathematical constants, you've seen them in science classes, you've heard them in your prior math classes, but I don't know how familiar you are with E, so let's take a moment to talk about it. E is an irrational mathematical constant, which means irrational in the same way that pi is a irrational thing, that these numbers, that decimal there, does not repeat. It is an irrational mathematical constant. It approximately equals 2.71828, and so on and so forth. You may have seen it in a science class previously where they kind of rounded off to 2.718. That is not unsurprising. That is called a natural base E. It is defined as a big, messy thing that as it approaches positive infinity, 1 plus 1 over n to the n approaches E. Yes, I know. We're not worried about that. But I do want to give you guys a chance to get a little bit better of an understanding of the number E and of the constant E and what that means. And we're going to be talking about E as we continue to get into logarithms, and you might be wondering why. But if you go into this next slide, I'm not going to play it now. You guys can play it. You'll have access to these. Right here, this will give you a way better understanding of the number E. When you are all done, it is not super duper long. It is a relatively comfortable watch, so you do have that to go by. But the reason I'm talking to you about this and the reason that I'm bringing E up is because you can use E as a base in a logarithm. The same way that most of our things, we know that if it doesn't have a base written, it's base 10, or you guys have been turning exponential forms into logarithms and using their different bases. So you've seen base 2, you've seen base 8, you've seen even base 15, whatever the number may be. You've seen other variables kind of put into place to get used to the format change. But you can use E, the number, as a base in a logarithm. But when we do that, we don't just call it a logarithm. We don't say log and then use the base E at the bottom. It does have a slightly different thing to it. When we do that, when we say a logarithm with a base E, like you see here in the middle, you see a log E, log base E of x, we call that a natural logarithm. This is an L, by the way. A lot of people try to write it as a capital I. It is natural logarithm. It's kind of backwards to think of it that way. Think of it as log natural. So that is a lowercase l n x. So the natural log of x is really the same thing as log base E of x. So a logarithm that has the base of E is referred to as a natural logarithm. Rather than saying log base E of x, we say the natural log of x. E and x are twins. E to the x power is the amount of growth after a certain amount of time, and the natural log is that amount of time that it takes to reach that level of growth. The same way that you were turning other exponential forms into logarithms and you were just taking the pieces and moving them around. If the base of that exponential form had been an E, for example, E to the second power, that's when natural logs would become into play rather than using regular logarithms. We're going to say natural logarithm instead. Natural logs are just logs that have a base of E rather than a base of a different number. So what I'm going to have you do, if you did not pause me to watch that video from the other slide, then you are going to close me now, go get a good understanding of E, and you will be on our way. Tomorrow, we're going to look at the graphs of natural logarithms and the graphs of regular logarithms, base 10, base 2, and some other examples. And we will continue our unit. I'll see you then.